Hey everybody, this is Mike Schrenk. Welcome to this series of 10 bot demos and code reviews for the book, Developing Bots with Selenium Python. If you got here via a link from the book, well, thank you. If you got here because you used a shared link, well, thank you as well. But please remember to like and subscribe below.
The creative misapplication of technology.
Hey everybody, it's Mike. This is project 9 in a series of 10 projects that go with my book, Developing Bots with Selenium Python. I wanted to do something kind of fun toward the end of this series because we've been doing a lot of CAPTCHA solving and we've been parsing and aggregating and buying cups. So I wanted to do something a little bit fun. So I wanted to write a bot that played a game, okay? Also, this bot ties in really nicely to the next one. So basically the next project is the headless version of this one. The engine around this game comes from the Tic-Tac-Toe project. Tic-Tac-Toe project, you can go look it up. They're on GitHub. That's where I got this. I did, however, load it to the Mepso server because just in case something changes after publication, I want this bot to still work and not fail because something moved or something. The game is the way you remember it. You get first move, you're always 0. The game will respond almost immediately. You do your best with your strategy. You notice that we got a block here. Okay, I'm going to come over here and block his win. Looks like this game is going to be a tie. And it is. It's actually, it's pretty good. It's probably better than my bot as far as being able to win the game, but that's really not the point here. I also chose this as an example because, as you can see when you look at the source code, this is all active content over here. It points out Selenium's ability to handle active content. All right, let's go ahead and run this bot. What you're going to see here primarily is a lot of really nice logging going on. Notice every move is logged. Oh wait, what's happening here? Oh my God, the suspense. It looks like it's going to be a tie. All right, good enough. If we have a tie, you recognize that the game is over. But the one thing that's really super nice over here is all of this really beautiful logging that goes on. We have a record of every decision that was made. All right, let's go ahead and look at the code. It's code review time. There are actually 2 pieces of code realized. So 2 things that I recognize right away is that I'm going to have to have some way of naming the squares and referring to them. And so basically I just decided to go 0 through 8, top to bottom, left to right. The other thing I decided early on is that I was going to have a separate library with some functions that I was going to use over and over again. And one of those is initBoard. And you can see all it does is it creates that array and it sets it all to dots. And I decided that a dot meant that the square was not used. If it has an O, that's for us. And if it's an X, that's our opponent. One of the other little functions that I wanted to have was readBoard, and basically this reads the contents of the board and puts it into an array. And then the other one I wanted to have was something called showBoard. This takes the contents of that array and it prints it out like you saw in the logs, those nice little game board. This is what generates that. Then I also have one where we figure out what our next move is, and this is not terribly elegant. Basically all it is a bunch of logic, and it just says when this happens our next move should be this. I think it's pretty comprehensive, but it could probably be improved on. In fact, I know it could be improved on. So anyway, that's what we have there. So the end product of this function is it tells you the index of the next square where you should move to. That's basically what it tells you. All right, let's see how we put this all together. Again, we're using our framework, which we developed in the second project. So we're not going to talk about initialization or shutdown or anything. Again, here is our game board. Here we import our game library, and then we start the game. This is the URL to where the game lives. We download the game, and basically it's ready to go out of the box. So the first thing we do is we make our first random move, and we take our first move is just a random move from 0 to 8. If we were strategic, we'd probably always pick 4, but we're not doing that right now. And then we go into this big while loop. So we just basically keep playing until there's a resolution to the game. We count the number of moves that we're making. We show the board. Again, this is what show board is really more like log board, because it puts it out to the console and also puts it out to the log file. Tells us what our next move is going to be after we go to next move. And again, we pass it the array. So basically this R board array is basically the status of the board at any given time. This kind of stuff should be looking pretty familiar to you now. So here we are getting an ID. This is the ID of the cell that we're going to say is our next move. And we get that from next move. So once we're in the loop, we wait just a short little bit of time. We count the move. We read the board. We get the next move. We make the next move. Here we do a find element by ID, and again, the ID is the ID of the table cell, which is our next move. We see if the game is over. The way we do that is we get the contents of the page, and we basically just look for some text. This is the easiest way of doing this. It's a little brute force, but it's not too bad. But as soon as game over equals true, we fall out of this while loop. And then we show the final board, and then we exit gracefully through the framework. That is it. We will pick this up again in Project 10, where we do this in headless style. I'll see you then.